Today's lesson is on first order separable differential equations. First order just means it's the first derivative. And then separable means we're going to be able to separate out the variables, primarily or usually x and y. Okay. Before we get into that, we're going to determine whether or not the function is the solution to the differential equation. So this is a differential equation because it is an equation that involves derivatives. So this is the second derivative. This is just our function. So if y is cosine, y prime is going to be a negative sine of x. Y double prime is negative cosine of x. So if I plug that in, my second derivative is negative cosine plus y, which is cosine of x. And if we add those together, we do in fact get 0. So this one is a true equation, which means that is a solution. 2e to the x, if I take that derivative, is 2e to the x. If I do it again, it's still 2e to the x. So the second derivative is 2e to the x, and then we're going to add that to y, which is 2e to the x, which does not equal 0. So this is not a solution. Okay, now what we're going to do is solve differential equations. And the process we're going to do this is we're going to separate then we're going to integrate. Then, if possible, we're going to solve for y. Okay, so we separate the variables. So we're putting all the x's on one side and all the y's on this side. So here what I'm going to do is just multiply this dx over. So dy is going to equal 2x dx. So I have x's all on one side and y's all on the other side. Then we're going to integrate both sides of this equation. So the integral of dy is just going to be y. The integral of 2x is x squared. And then we have plus c. Always have a plus c. This one, I'm going to multiply by dx and then divide by y. So this is going to be dy divided by y is going to equal 2 dx. You want to leave as much stuff on this side of the equation as you can. Okay, so let's integrate. So here I'm going to integrate. This is going to be the natural log of the absolute value of y. This side is going to be 2x plus c. Integrate. Okay, now we need to solve this for y. We're going to do that by raising both sides to the e. Okay, well, e to the natural log of y is just going to be y. Then we have e to the 2x plus c. This is going to happen a lot in these equations. So I want you to consider rewriting this as e to the 2x times e to the c. Okay, we can do that using our properties of exponents. Well, e to the c is just a mystery constant. We don't know what it is. So e to the c can still just be c, because this is just we don't know what c is. So I can rewrite this as e to the 2x times the constant, which we are going to write this as c e to the 2x. This is a very, very common thing we're going to do, and you're going to see it over and over again. Okay. So for this one, dy is going to equal 3x squared dx. Then we'll integrate. Integral of dy is just y. Integral of 3x squared is x cubed plus c. Okay, this one, we're going to have dy over y squared is going to equal 3 dx. So the integral of 1 over y squared is negative 1 over y. This is going to be 3x plus c. So I'm going to multiply over the negative. So this will be negative 3x. And c is just a constant. So I can make that negative, but that's not really going to change anything because it's just a constant. So if 1 over y equals 3x plus c, then y is going to equal 1 over negative 3x plus c. For e, we can cross multiply. So this is going to be y dy equals 2x dx. Then we'll integrate. So the integral of y is going to be 1/2 y squared. Integral of 2x is x squared plus c. So y squared is going to equal 2x squared plus c. So y is going to be plus or minus the square root of 2x squared plus c. And later on we're going to see the plus and minus can be determined if you have an initial condition. This one, when we cross multiply, is going to be 2x dy equals y dx. So then to separate it, we're going to have dy over y is equal to dx over 2x. So we'll integrate this. The integral of 1 over y is the natural log of y. This one's going to be 1/2, if I pull out the 1 over 2, times the natural log of x plus our constant. So I'm going to raise both sides to the e. Okay, and then I'm going to do that same trick on this side. So y equals, this is going to be e to the 1/2 natural log x times e to the c, which is just a constant. So this is going to be y equals c e to the natural log of x. I can make this to the 1/2. So here, the natural log of e to the x to the 1/2 is just going to be x to the 1/2. And I don't need the absolute value anymore because I couldn't plug in a negative anyway. Okay, so this one's going to be dy equals 1 over 1 plus x squared dx. So y is equal, the integral of 1 over 1 plus x squared is tangent inverse. Okay, here, we're going to end up with 1 plus y squared dy equals dx. Integral of 1 is going to be y. Integral of y squared is going to be 1/3 y cubed. That's going to equal x plus c. Now in this case, there's really nothing we can do to solve for y, so we're just going to leave it like that. Okay, here we're going to have dy is equal to 2 root x dx. So y is going to equal 2 times 2/3 x to the 3/2 plus c. So 4/3 x to the 3/2 plus c. Okay, so here I'm going to divide this over and multiply the x. Normally, I'd say leave the constant with the x, but in this case, I'm going to pair it with the 2y. Because the integral of 1 over 2y is just going to be the square root of y, because the derivative of square root is 1 over 2 root y. And then we'll square it. So y is going to equal x plus c squared. And you do need to, you can't just say x squared plus c squared, because we're taking that entire quantity and squaring it. Okay, here I have 1 over 2 root x, so we're going to have dy is equal to 1 over 2 root x dx. So the integral is going to be y equals the square root of x plus c. Here we're going to have 2 root y dy equals dx. So this is going to be 2 times 3 halves y to the 2/3 equals x plus c. So this would be 3/4. Let's try this again. 2 times y to the 3 halves, and then we're going to multiply by 2/3. So this is going to be 4/3, so I'm going to multiply that over. So this will be 3/4 x plus c. Again, if I multiply that by a constant, we're still good. So y is going to be 3/4 x plus c to the 2/3. All right. So here I'm going to have dy over 3 minus y is equal to x dx. Okay, so this one's integral. We'd have the natural log of 3 minus y, but since we have this minus y here, if I took its derivative, we'd have the chain rule, so we'd multiply by negative, so we need to undo that. That's going to equal 1/2 x squared plus c. So we're going to solve for y here. So this is going to be negative 1/2 x squared plus c. Raise both sides to the e. So this side is just going to be 3 minus y. This side is going to be ce to the negative 1/2 x squared. We'll subtract 3. And then multiply by a negative 1. So if negative y equals this, then y is going to be 3 minus ce to the 1/2 x squared. All right, this next one's going to be a long one, just warning you. So here we're going to have dy over y 3 minus y equals dx. So why is this a long one? Well, in order to integrate this, I need to use partial fractions. So remember, partial fractions, we separate out the two factors. So 1 over y 3 minus y is going to equal some number I'm going to call a over y plus some number we're going to call b over 3 minus y. So remember, partial fractions is just a strategy for undoing the common denominator and separating out those fractions. So 1 is going to equal a times 3 minus y plus b y. So remember, that's what we'd have to do to get a common denominator. You need to multiply this by 3 minus y over 3 minus y. You need to multiply this by y over y. So this is our resulting equation that we want to solve. And the strategy is to pick convenient values of y. So I'm going to start with, let's let y equal 3. Well, why would I do that? Because that means here, that goes away, and I'm just left with b times 3, which means my b is equal to 1/3. Okay, my second convenient value I'm going to pick is 0, which means 1 equals a. 3 minus 0 is just 3. So a is also 1/3. Okay, so now we take that and rewrite our integral here. So rather than 1 over y, this is now going to be a over y, so 1/3 over y, minus b over 3 minus y, which is also 1/3. dy equals dx. So now we'll integrate. So the integral here is going to be 1/3 natural log y. This one's going to be negative 1/3 natural log 3 minus y, but because of this negative, we'd have to undo the negative. Sorry, this is plus. So this would be plus, but then because of that, we get a negative there. Equals x plus c. All right, we've done the integral. We've done partial fractions to get that integral. Now we need to solve for y. Okay, so this is going to take some fancy algebra here. First, I'm going to factor out the 1/3, which will leave me with the natural log of y minus the natural log of 3 minus y. Okay, I'm going to multiply the 3 over. So this side will be 3x plus c. Here, if I have a natural log minus natural log, we can use the quotient rule. So now we have natural log of y over 3 minus y equals 3x. So I raise both sides to the e, so we're going to have y over 3 minus y is going to equal c e to the 3x. So remember, if I've got e to the 3x plus c, I can just pull that out front. Okay, how do we solve for y? I'm going to multiply this over, so I'm going to have y equals 3c e to the 3x minus yc e to the 3x. I'm going to add this one over, so I'm going to have y plus yc e to the 3x equals 3 times c is just c. Factor out the y. And then divide. So y is c e to the 3x over 1 plus c e to the 3x. Okay, so this one's going to be dy over 1 minus y equals dx 1 minus x. So this is going to be the natural log of 1 minus y, make it negative because of that, equals negative natural log 1 minus x plus c. Okay, the negatives are going to go away on both sides, and then I'm going to raise both sides to the e. So e to the natural log 1 minus y is going to equal e to the natural log 1 minus x plus c. So 1 minus y is going to equal c e to the natural log 1 minus x. So 1 minus y is just going to equal c 1 minus x. So I'm going to subtract 1. And then multiply by negative 1. So I have 1 minus c 1 minus x. All right, for this one, we're going to use that same rule that we've been using, that we have 5e to the 2y, 2x, and then we can rewrite e to the negative y. So I'm going to have dy over e to the negative y equals 5e to the 2x dx. Well, this is just e to the negative y in the denominator is just e to the y. And we integrate. This will be e to the y equals 5 halves e to the 2x. Okay, then I'll take the natural log of both sides. Natural log here is just going to be y. And there we go. For these next examples, we're going to solve the differential equation, and then we're actually going to find the value of c. So it's still going to start off the same. So this one's going to be y dy equals x squared dx, and we'll integrate. So 1/2 y squared is going to equal 1/3 x cubed plus c. Now you can solve for c at any point. If there's a point in the equation that makes it easier to solve, then you can do that, or you can wait until the very end. It doesn't matter. You'll get the same thing either way. So I'm going to go ahead and solve first. So I'm going to multiply by 2. So this is going to be 2/3 x cubed plus c. Then I'm going to take the square root, which would be plus or minus the square root of 2/3 x plus c. So we have solved this, but we have an initial condition, so we can actually make the decision of whether this is the plus or the minus. Since our result is going to be a positive value here, this is going to be a positive square root, not a negative square root. So I'll solve for my initial condition, 1, 1. So 1 equals positive square root of 2/3 times 1 plus c. So we're solving this for c. I'll square both sides. And then subtract 2/3. So c is equal to 1/3. So now we put all this together. My function is y equals positive square root 2/3 x plus 1/3. Here we're going to have y dy equals x dx. Integrate. And then solve. So y squared equals x squared plus c. Y is equal to, again, plus or minus the square root of x squared plus c. In this case, since my result of my initial condition is negative, this one's going to be a negative square root. So we'll go ahead and plug in our condition. So negative 4 is going to equal negative square root of 3 squared plus c. So if I square both sides, we're going to have 16 is equal to 9 plus c. Subtract 9, and c is 7. So my final equation is negative square root x squared plus 7. Here we're going to have dy over y equals cosine of x dx. So we're going to have the natural log of y is equal to sine of x plus c. So raise both sides to e. So this is going to be c e to the sine of x. Then we'll plug in our initial condition. So our initial condition is y is 3 and x is 0. Sine of 0 is just 0, so my c is 3. So our final equation is y equals 3e to the sine x. Now we're going to find y when x is pi over 2. Okay, sine of pi over 2 is 1, so this is going to be 3e. Okay, so the graph of f prime is shown below. If f of 0 is 3, we're going to solve for the equation. So f prime is also dy dx. So dy dx is this, a line that has a slope of negative 2 and a y-intercept of 4. So we'll separate our variables. So y is going to be negative x squared plus 4x plus c. If f of 0 is 3, this will be 0, this will be 0 plus c, so my c is 3, which means f of x is negative x squared plus 4x plus 3. So this one says at each point on the curve, the slope is 4xy. If the curve contains 0, 4, then the equation for y is. So these are all the same thing, it's just how they're phrased is different. Slope is dy dx. Separate our variables. And then integrate. So we're going to have the natural log of y equals 2x squared plus c. So y equals c e to the 2x squared. Then we'll solve for our initial condition. So 4 equals c e to the 0, because our initial condition is 0, 4, which means our c is 4, which means our equation is y equals 4e to the 2x squared. Okay, our next problem says find the equation of a curve if the slope of the normal line passes through x, y, and 0, 2, and the curve passes through the point 2, 0. All right. So if the slope of the normal line is going to be, we'll just use the slope formula, so y minus 2 over x minus 0. The slope of the tangent line, which is going to equal dy dx, is going to be the opposite reciprocal of that. So I'm just going to make this a negative x over y minus 2. So that's our differential equation that we're going to be solving. So if I separate my variables, we're going to have y minus 2 dy equals negative x dx. So 1/2 y squared minus 2y equals negative 1/2 x squared plus c. We're just going to go ahead and leave this. We're going to go ahead and plug in the 0.20. So this would be 0 minus 0 equals negative 1/2 2 squared plus c. So this would be 4 over 2 is a negative 2. So c is going to equal 2. So we're going to have 1/2 y squared minus 2y equals negative 1/2 x squared plus 2. Okay, so we have one more here. We have a differential equation and an initial condition of 2, negative 2, and we're figuring out which of these satisfies that. So we have y dy equals 4x dx. 1/2 y squared is going to equal 2x squared plus c. Okay, so y squared is going to equal, I'm going to multiply by 2, so 4x squared plus c. So y is equal to plus or minus the square root of 4x squared plus c. My initial condition is negative 2. Okay, so when I plug in a number, I'm going to get out a negative. So we have the negative option. So looking at my multiple choice answers here, we're down to these. I can go ahead and plug in the initial condition or just assume it's 12 since that's what those options are. If we plug in the 2, we're going to have negative 2 equals negative square root 4 times 2 squared plus c. So 4 equals 16 plus c. So c is in fact negative 12. Okay, so the difference is this. So why is it root 3 versus 1.5? Well, we need this to be positive. So we need 4x squared minus 12 to be greater than 0, which means 4x squared needs to be greater than 12, which means x squared needs to be greater than 3. So x needs to be greater than the square root of 3. So that is our introduction to differential equations and solving them by separating them and integrating them and using all of our different techniques that we've learned so far.